This section that we're going to be doing, this is section 2.2 of your textbook. We're going to look at first histograms. So I've brought up an example on how to do that. What you want to do is try to figure out how many bars you're going to have in your histogram, because this is going to be something of a bar graph. So this says 6 bars. So I want my histogram to have 6 bars. Each bar basically corresponds to a range of values in the data. So if you look at our data here, we go anywhere from 9 to 14. So let me first get the range of values that we have. My highest value is 14. My lowest value is 9. Now what I would like to do is take and distribute that range among the 6 bars. If I take 5 and divide it by 6, I get this number. Now, such numbers are what we're going to be using in making a table for these values. And choosing a number that's unusual like this is not going to be very helpful for us. So what we want to do is, if it's under 1 like this, let's round it up to 1. Then next, if you'll notice, inside of some of the data, some of it has 1 decimal point. So what I really want to do is something like this. I want to make a table of values. So I'll have my data. And I want to do it in, I don't want to list all 50 pieces of data. Instead, I would just like to list the data values and their frequencies. And actually they typically don't draw that little line, so I'm taking it out. Now let me start here. Here's what I want to do. I want to, my thickness is 1, or what they call the class width is 1. So I can go 9 to 10, then 10 to 11, 11 to 12, 12 to 13, 13 to 14. And then I'll just make note of the frequencies of these various things. However, there is a problem. As you can see, 10. I want to count it in this range, but here I would have to put it in 2 different categories. Now, there is a way to fix this. But what you want to do is look at the data. I'm still going to do my class width as 1, but I'm going to look at the data here. I notice the data has 1 decimal point. So what I want to do, before where I said that 10 was in 2 categories at once, there is a way to prevent that from happening. And it's to use 2 decimals in making up the table. And then this is what I'm going to do then. Since I said use 2 decimals, I'm not going to start at 9. I'm going to start at 8.95. Now my class width is 1. Now let me go ahead and draw the next class. See what happens here is, since this 9.95 has 2 decimal places, it's not part of the data. So it makes nice division points of the data. Same with 10.95. So you can see, if you look, I have a total of 1, 2, 3, 4, 5, 6 categories, if you will, 6 ranges, or better yet, these are actually called classes. So now what I'm going to do is go through look through the data and see how much of my data is between these two ranges. So this is going to include 9 all the way up to 9.5, and I saw the frequency was 4. Now we know there's 50, I think there's 50 data points total. Yeah, 50. Now anything in the 10 ranges is next. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And basically the 11s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The 12s, I have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, there's no 13, so I got a 0 here. And there's only 1 in the last range. So this table is going to tell me how to draw the graph. I'm going to use this area here from which to draw. I need to go up to 14 on the frequencies. As before, the frequencies will put along the vertical axis, and then the bottom we'll just put class. So we'll start at 8.95. And once again, I have misjudged how far I was going to need. But anyways, all you do here, let me put my account here, 2, 4, 6, 8, 10, 12, and 14. So for the first class, I only have 4. Now these are slightly different than bar charts. And once again, you have to imagine I'm doing things with straight edge here. They actually line up right next to each other, so it's not typical to put gaps or space between them. My next one is 14, and I think, to be honest, I did make a mistake. My highest class is actually, my highest value is actually 20. I guess I'll put it up there. And the next one goes all the way to 20, in fact. You don't have to do the shading. I'm just doing it to make it easier on the eyes. The next one has 11. So as before, you can go halfway between 10 and 12. Then 12 to 13 doesn't have anything. And then finally we have 1 in the last category, so I'll just kind of put it down in here. And this here represents a histogram. There's the scaling and all that is up to you, but what I've tried to do is show you how to make it so it's going to work out well. The reason for going to 2 decimal places was so that I would be able to go between the data values when I broke up these things into classes, so that not one of these things possibly could fall into 2 classes at once. Secondly, I used 0.05 that way. So like what I did is I took my lowest value, 9, and I subtract 0.05, and that's how I got the 8.95. I'm using 0.05 because that's 2 decimal places, and anytime you end a decimal with a 5, it's always going to be a good number to work with. That's just the last one is just how it stacks up. So I didn't do anything except take 0.05 away from the very first data point. Now this time you're told to find a frequency polygon, and they've given you a table. You could do, if you wanted to, you would be able to use this table to create yourself a histogram right on the spot. But a frequency polygon is a slightly different type of graph. It doesn't use bars, it just uses points. And in fact, what we do here is we create a new place here called the midpoint. So how I get the midpoint is I take the average of these two numbers. So 41.5 plus 46.5 divided by 2. That equals 88, so that's equal to 44. Now you can pretty much generate the rest of it. Because these class sizes are size 5, I know that the next one will be 49, then 54, then 59, 64, and 69. Basically then, what I'm going to do is I'm going to use this point here, if you will, with this frequency to make my graph. As before, I'm going to put frequency along this side. You could put midpoint down here, or let me actually make one of these age at inauguration. That sounds good. So we could put age at inauguration. And what's the largest of my frequencies is 14. Let me check, we'll make sure, yes, 14. So I might be able to go by twos again. Let's try 2, 4, 6, 8, 10, 12, 14. It looks like I've made it. And so now let me go ahead and put my numbers in. The midpoint is 44, 49. So what you might do is this. You might just put in 44, 49, 54, 59, 64. How high did I need to go? 69. And then what you do then at that point is I look at 44. I'm going to pretend 44 had a frequency of 4. So what I'm going to do is right above 44, I'm going to put a dot. Same thing next to 49, or above 49, I'm going to put a dot at 11. '54 has a 14 frequency, so I'm going to put a dot all the way at the top. And then 64 had a frequency of 4. And then 69 had a frequency of 2. And then what you do is you connect each of these with a straight line. I'm trying to do the best I can here. Now there is a little bit of difference between what we had before. Here you come back one less down to, actually I made a mistake there. That should be 39, so come down one more 39. And then over here put 74. And that way you do, it's just courtesy to do this. You basically, after you've used up the last data point, then the graph comes back down to the x, or the horizontal axis. And so that takes care of the time graph, or the frequency polygon. Sorry, I did put frequency polygon. Now the last style of graph that we're going to be using is the time series graph. These are useful if we're seeing things, like seeing trends, seeing how things are tending to go. So this here, we have CO2 emissions, and we have for the Ukraine, the United Kingdom, and the United States. For the United States, they want us to make one of these time series graphs. So it's the same style of look to begin with. I need axes just as I did before. Scale is interesting here. If you look at the data, it is given in terms of millions. So what I'm going to do, and if I look at my lowest million, the lowest million is about 5.3 million. So what I'm going to do is I'm going to do 5.3, 5.4, 5.5, and I think I need to go up to about at least maybe 5.9, so it's 7. Now, in here, what you could do, you could say in millions of units of CO2. And down here you could put the year. And the years, we go from 2003 to 2009. And then basically I just try to graph. So if we look at year 2003, I see that I have 5.68 million. So that's kind of close to 5.7 million. So I'm going to go right above 2003 and put a dot right, I mean almost right at 5.7. It's just a hair underneath of that. Next, for the year after that, 2004, I have 5.79. So that's close to 5.8. So there was an increase. You can see this as they went from 2003 to 2004. And you got to watch this. If I linger too much on a spot, it wants to act like I've made a choice from a menu. Now the year after that was 5,826. So that's about a quarter past that 5.8. And then we have, where am I at? That was 2005. 2006 is 5.737. So above 5.7, above 5.7, about 0.37, so about there I'm guessing. Okay, that looks like 0.5, but I can live with it. Next is 5.83. So 5.8, it's right here, and then about a 3. Next, 5.656 for 2008. So 5.6 is right here, and 5.6 is about halfway. Put a dot there. And then finally 2009, we had almost exactly 5.3 million, which was my start. So then I've got all my dots, and then what you do is you just connect them with straight lines. You do not need to do like I did before and end it at 0 or make it go down to the x-axis. You can just leave this one up like that, but you still connect it with straight lines. And there we have a time series graph.